Let's take a look at problem number 21. It says find a solution to the system equations with the augmented matrix. Doesn't really say what technique to use here. Solving linear systems of equations using backwards substitution. Step 1. Using write. Now there's different ways of doing this, so I'm going to write this as geared toward matrices. Actually, I never have put this in words before, so this is like version 1. Get everything with a variable on the left side, numbers on the right side. Then line up like terms. Step 2, write down the matrix corresponding with this system of equations. Drop the variables and equals. Step 3, use row operations to put the matrix in Rref format. Row echelon form. Row echelon. I can spell. Echelon form. Step 4. Put the variables and equals back in. And now you should have, I'm writing this in terms of 3 equations, 3 variables. So you should have three equations now. So step 5, solve the third equation for z. Now plug this value. Now plug the z value into the second equation and solve for y. And step 7. Now plug the y and z values into the first equation and solve for x. A lot of steps. Okay. So let's take a look at this problem. This is problem 21. And we got 1, 2, -1, 4. Let's try that again. Okay, here we go. 1, 2, -1. Okay, 0, 2, 1. -3. 0, 0, 2. -4. That's nice. There. Okay. Step 1. Get everything with variable on the left side, numbers on the right side. Then line up like terms. That's been done. Write down the matrix corresponding with system equations. That's been done. Now step 3 has only been partially done. It says use row operations to put the matrix in Rref row echelon form. When I say it's only been partially done, Rref form says that your first entry in each row, that's like this one here, and this one here, they should be 1s. and then you should have zeros below them. Now, you cannot have a 1 right here. If I have a 1 in this first spot, then I either have to have a 1 here, or so forth. It can't be directly underneath it. It's got to be at least 1 to the right. Well, I'm going to put it in row echelon form. So I'm going to take row 2, and I'm going to divide it by 2, and that's going to give me my new row 2. And row 3, to get a 1 here, I need to divide that by 2. So I'll take row 3, divide by 2, and that's going to give me my new row 3. Now technically you don't have to have them as 1s in order to do backward substitution. What is going on with this there? Let's say I'm dragging a pen, but no, I'm not. Okay. Row 2, divide by 2. 0 divided by 2 is 0. 2 divided by 2 is 1. 1 divided by 2 is 1/2. Negative 3 divided by 2 is negative 3/2. Now our last row, divided by 2. 0 divided by 2 is 0. 0 divided by 2 is 0. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. And now it's in row echelon form. Let's see. Step 4. Put the variables and equals back in. Well, this is going to be x, y, z, and this is where my equals is going to be. And this will be x, y, z, and this is where my equals will be. This is x, y, z, and this is where my equals is going to be. So for our first equation, we'll have x plus 2y minus z is equal to 4. Our second equation will be y plus 1/2 z is equal to negative 3/2. And our last one will be z is equal to negative 2. That's step 4, I guess. Step 5. Remember, we have 3 equations now. We have equation 1, equation 2, and equation 3. Step 5 says solve the third equation for z. Well, this one's real easy. It is if it's in row echelon form. That's already solved. So z is equal to negative 2. Well, step 6. It says now plug the z value into the second equation and solve for y. Well, our second equation was y plus 1/2 z is equal to negative 3/2. And we just said z was negative 2. So I'll put the negative 2 in for the z. One-half times negative 2 gives us negative 1. Equals negative 3/2. And take the negative 1 to the right side and becomes a positive 1. So 1 minus 3/2, which gives us negative 1/2. This is a mixed number. I take the 1 times the 2 gives us 2 and add the negative 3, and that gives us our negative 1. Denominator stays the same. Well, step 7. Now plug the y and z values into the first equation and solve for x. So our first equation is x plus 2y minus z is equal to 4. And x we don't know. Y we said was negative 1/2. So I'll put in negative 1/2 for the y. Minus z, which was negative 2, equals 4. Well, 2 times negative 1/2 gives us negative 1. Negative negative becomes a positive 2, equals 4. Negative 1 plus 2 is 1. Take the 1 to the right side and becomes a negative 1, and we get x is equal to 3. So our answer, we have 3, y was negative 1/2, and x, or z, is equal to negative 2. So 3, negative 1/2, and negative 2. Our answer would be A, using backward substitution. Now we can use the Rref method on this. So what I can do is take that matrix, plug it into our calculator, and just do the Rref. So I got 1, 2, -1, 4, 0, 2, 1, -3, 0, 0, 2, and -4. So let's go put this in. So I'm going to do a second x and -1, go to my matrix menu. On a T83, you just have an matrx menu. That's T83, not a T83 plus. We're going to go over to edit, so I left arrowed, and press enter on A. And then I'll do 3 enter and 4 enter. And I'll type in each number, pressing enter after each one. So 1 enter, 2 enter, -1 enter, 4 enter, 0 enter, 2 enter, 1 enter, -3 enter, 0 enter, 0 enter, 2 enter, -4 enter. And make sure you exit out after you get a numbers input. So you do a second mode to exit out. And now we're going to go through our Rref process. So we'll go to a second x and -1, right arrow to math, and up arrow to Rref. Make sure you choose the one with 2 R's. Enter. Then go back to my matrix menu. Do enter on A, enter again. Now I got decimals, but we know how to handle that. If you get decimals, you press math, enter, enter. And we get the same answers. The far right column is your answers. 3, -1/2, -2.